Okay, so in this part of the lesson we're going to be looking at sketching, at inserting sketches and then navigating within our sketch environment and using the sketching tools available to us. So the aim of this video is to get you familiar with the sketching environment, and I will not be going into a great deal about the commands available to us in that environment. However, there is a follow-up video to this lesson where I'll explore more deeply the sketching environment, and this will be a stop-start tutorial where I will ask you to stop the video at certain points to try out and play with the tools and commands yourself before we progress. So take a look at that video after this one to really get a deeper understanding of the sketching environment. So the sketching environment is a two-dimensional environment, whereas our modeling environment is three-dimensional. Now we create sketches within our 3D environment by defining a reference plane, or in other words the two-dimensional environment that we want to place that sketch within. So in order to do this we will often bring in datums. Okay, so I'm going to initially explain a little bit about datums. So let's create a new part. Left click on part/assembly. Okay, you will see in this create new panel that we have the ability to create a new sketch instead of a part. You can see it up here as well. Like it says, this is a standalone sketch. Most of the time we will be wanting to use our sketches within our 3D designing environment. So we create our sketches within our part. So we're going to keep our part/assembly selected. Then we will navigate to our generic blank template, left click, and we will name our part. Left click OK. And here we are in our 3D environment. So you may remember me describing our boxes in the middle here, our three squares, and these are datums. These are our global datums or default datums. Okay, I'm going to blank these out right now. Window pick them, blank. And now we're going to explore the concept of our 3D environment and a 2D environment. This here is our triad, and at the center is our world origin. Okay, so our three-dimensional environment is defined in terms of the X direction as our first dimension, the Y direction is our second dimension, and the Z direction our third dimension, hence three-dimensional. Now any point in our 3D space can be defined using an X, Y, Z coordinate. We can travel a direction in the positive X direction or negative X direction, a distance in the positive Y direction or negative Y direction, and travel a distance in the Z direction or negative Z direction, and we'll end up with a coordinate X, Y, Z. So based on this, it follows logic that a two-dimensional environment will be based on two axes. So let's unblank our datums, right click, unblank all. So our datums define a two-dimensional environment. They define a plane. So let's take a look at our top plane, this top datum. We can navigate into our top view, and you can see that in this plane we have an X, Y axis. Okay, this plane is the XY plane. We can define points in this plane by using a two coordinate system, an X value and a Y value. Okay, so likewise we have our front plane, which is an XZ plane. Okay, it is defined in terms of the X and Z axis. Lastly, we have our side plane, defined in terms of the Y and Z axis. This is our YZ plane. Let's go back to our auxiliary view. So now let's draw a circle constrained to one of our planes. So in the wireframe tab, I'll select circle. I'll then align it to a plane. Let's align it to the top down XY plane. Place the center at our global origin and we'll give it a radius. Confirm the operation. Okay, now you can see that this circle is constrained to our XY plane. You see it has no Z value. It is a two-dimensional planar drawing. Now, we can create our own datums anywhere within the 3D environment with any orientation, with their own local coordinate system that is not based on our global X, Y, and Z axis. So let's do that. To insert a datum, we right-click anywhere in 3D space and navigate to Insert Datum. Alternatively, we can access this command through the Insert drop-down menu, Insert Datum. So right-click, left-click on Insert Datum, and this will bring up our Datum command input manager. In here we have many options and fields that help us define our datum and its orientation. So let's bring in a plain view datum. So this will create a datum that corresponds to the 2D plane defined by our current view. So let's place this datum here, left click. We also have the ability to change the orientation of our datum, but I will not get into that right now. So we confirm this datum. Now you can see that this datum has its own X and Y axis. It has its own local coordinate system, and these axes are not in line with the global coordinate system. Okay, so now let's bring in some more datums. We are going to middle click to bring up the last command, the datum command. Let's bring in an XY datum. This datum is aligned with the XY plane. Left click. Again, we will cover the fields in this datum input manager as we progress further down the line. For now, we're just trying to get across the concept of datums. So confirm the operation. Middle click. Let's bring in an XZ datum. Okay, so you can see that this datum is aligned with the global XZ plane. However, it has its own XY coordinate system. Finally, a YZ datum. Okay, this is aligned to the YZ plane. However, it has its own local coordinate system. Now I'm going to draw a circle again, but this time I'm going to align it with this plane. Our center is here. We place it here, for example. In terms of this datum, this point has an X value and a Y value. In terms of our global axis, it has an X, a Y, and a Z value. Okay, so let's confirm this. Now I'm going to use the copy command like we saw in the previous part, but this time I'm going to use my frame to frame copy. Okay. My entity is my circle. My from frame is this datum. And now I can copy this circle with reference to this plane to other planes. And now you can get an idea of how our plane systems work, our two-dimensional environments. Now a plane of reference can be defined not only by a datum, but also by a plane of face, a flat surface, a two-dimensional surface. So let's bring in a cylinder. Left click on cylinder. Let's define the center, the radius, and the length. Middle click. So here, if we change our entity filter to face, our cylinder is made up of 3 faces. 1, 2, 3. I'm going to change the color of this face to make it more distinct. So here we have our 3 faces. Now this face is a planar face. It is flat, two-dimensional face. Likewise, this is also a planar face. This face, however, the green face, is not a planar face. So let's try our copy command again. Let's select our entity here, change our entity filter to curve, middle click to progress to the next field. Let's pick our frame, this datum, and then our 2 frame. Okay, so we are able to define our 2 frame as this planar face. We can copy it to this plane. However, we cannot copy it to this face. This face is not a planar face, it is not a planar surface. Confirm. Okay, but we can also insert datums on faces. If we use this first option and hover our cursor over an entity, in this case the faces, we get a preview of the datum. If we place our datum on this face, this datum is going to define the same plane of reference that this planar face does. We can also place a datum on this cylinder. The point at which we place the datum, it will be tangent to that cylinder surface. Tangent meaning that the datum and the cylinder face touch, but they do not cross each other. They do not intersect. Confirm. Let's place another datum on this face. Confirmed. Okay, so let's use our copy command again. We're going to copy from frame to frame. Let's pick our circle entity. This datum is our frame. And now we can copy it onto these datums on this face. And see how they are aligned with the face of this cylinder. Okay, now we know what the datums do and how we can place them. We can now insert a sketch. We can insert a sketch in the same way as the datum by right-clicking, Insert Sketch, Insert drop-down menu, Insert Sketch. So right-click, left-click Insert Sketch, and here is our input manager. we are asked to define a plane for our sketch to be on. This plane can be a datum plane or a planar face. When you select a datum plane or a planar face, the sketch is aligned with the plane and the sketch geometry is created on that plane. So if the plane moves, then so will the sketch. So if we create our sketch on this surface, now I should draw your attention to this option, the Use Centroid Defined by Plane. We usually want to check this box and see what happens when we do. Okay, you saw this centroid, the center of our sketch, popped into the center of the plane that we picked. Okay, if we uncheck this, it's going to orient our sketch with the center being the center on our global XY axis. Okay, so for the most part we want to have this checked. So the center of our sketch is at the center of the plane that we place it on. So let's cancel this. Okay, so let's insert our sketch on the front datum, making sure that this is checked. When we confirm the operation, we are taking it into the two-dimensional environment as defined by the datum, the front datum that we selected. Now at this point, I recommend you pause the video here and take a look at the follow-up video to this lesson, the follow-up sketching video, where I go into greater detail regarding our drawing and our sketching tools in the Sketch ribbon tab. Okay, I've put all of this information in a side video because I want to progress in this tutorial and use some of my sketching tools to create a sketch that I can use in a 3D environment. So if you continue watching this video now, you may see me using some of our sketching tools that I will not fully explain. To get an understanding of these and also to practice using these, please watch the supplement follow-up video. Okay, so let's continue. In our 2D sketching environment, you will notice that we are still able to see our 3D environment and we're still able to navigate it. However, we're not able to pick or select any of the entities within our 3D environment. Okay? We are constrained to our 2D environment as defined by our front plane, and our 3D environment is only here as a reference. We can return to a planar view by left-clicking on the plane view icon in this document aware toolbar. We can then hide our 3D environment by left-clicking on the show target icon. This will hide our 3D environment and allow us to work cleanly within our sketching environment. Okay, so you will notice that our user interface is different. Our document aware toolbar is slightly different. We have far less ribbon tabs. We still have our quick access toolbar and our drop down menus. So if I'd come in and draw a simple shape in the 2D environment, and then I bring back my 3D environment, you can see how this shape is constrained to this plane. Okay, now I can exit back out into the 3D environment by using the exit icon on the far left of the document aware toolbar. Okay, this is the same way that we exit from the 3D environment into the root environment. In this case, it takes us from the sketching environment to our 3D modeling environment. And now you can see back in our 3D environment, we have our sketch and all of our other operations from history. Our sketch then serves many purposes within our 3D environment. We can re-enter our sketch by double-clicking on the sketch, or we can right-click, redefine. Alternatively, we can redefine the sketch from within our history manager by right-clicking on the operation and navigating to redefine. We can also edit our sketch. Okay, there is a difference between these two, the redefine and the edit, and I'll show you this difference later on. Okay, so let's erase this sketch. We're going to window pick it all and erase. Now I'm going to teach you a little bit about our constraints in the Constraint Ribbon tab. Okay, so constraints force conditions on geometry. There is a wide range of constraints to choose from, and there are also commands to analyze and solve the constraint system. So let's give you an example of what a constraint can do. We're going to draw a 2-point line anywhere in space. Left click to confirm. And now maybe we want to constrain this line to be horizontal. We can add a constraint to this line by coming into our horizontal constraint, left clicking, and then left clicking on our line. It makes it horizontal and throws in this icon. This icon says that there is a horizontal constraint attached to this line. So if we try to modify our line by dragging and dropping it, it will always stay horizontal. We can delete this constraint by selecting it and erase. If we try to modify our line now, you see we can drag it, and it is not constrained to be horizontal. We can also constrain our line to be at a certain point within space. Let's say we want to constrain this point of our line, the end point, to be at the center, the origin of our 2D environment. We can come into our constraints, select point coincident, select our first point and our 2 point, and confirm. Okay, this point is now constrained to the origin. You saw the line flip there. To fully constrain our line, we must add a dimension to it. We must give this line a certain length. We can do this by using our dimension constraints up here. Okay, our quick dimension command is a smart tool that will create a dimension based on our picking. So let's left click this icon, and we have our option panel pop up. This is like the input manager in the 3D environment. To access this, we can also right click, navigate to quick dimension, second from the right on the top. We can then pick the line that we want to add a dimension to, and this smart tool will automatically dimension our line. We left click, and then we can drag out our dimension to a point in space. We are then able to dimension our line by scrolling. I can input an exact number and press enter, and here we have our dimension. So this line is now fully constrained. If I try to move it, I cannot. I can modify my dimension by double clicking or right clicking on a dimension and left clicking on modify value, first icon on the left. Okay, I can change my step size by right clicking, navigating to step size. Now let's input another 2-point line. Now in the sketching environment we have some snapping tools that also relate to our constraints. They throw in auto constraints. As you can see here, when my first point approaches the y-axis, we have this auto constraint thrown in. And if I draw the line, we will have an auto constraint to the horizontal. So these snapping tools that throw in auto constraints can be very useful. However, if we wish to turn them off, we come into this icon, snap filter in the document aware toolbar, left click, and we can enable or disable the smart pick, or we can disable only particular constraints. So let's see what happens when we disable the smart pick. When we come in to draw a new 2-point line, we do not get the auto snapping. If I try to draw a horizontal line, it does not snap to be horizontal. Okay, we can add these constraints in later, but it is useful to have it done automatically using our smart pick, our snapping tools. Okay, so you will understand this more as we progress and how our constraints can be used. I'm going to delete these two lines, create a new 2-point line. I'm going to let it snap to the origin. You'll feel it snap in there, and you'll see an auto constraint icon pop up. So left click, left click again, confirm, and now I'm going to use my smart dimensioning tool, right click, quick dimension, to add an angular dimension between these two lines. So we left click on one, left click the next. Here we have our angular dimension. Left click to place the dimension. It doesn't matter where we place the dimension, but obviously we will want it somewhere where we can access and see it easily. Okay, we can now modify our angle. We can have a very precise angle, or just change it until we see something we like. Again, we can modify this dimension later. We can change our angular step size by right clicking, step size, let's give it a 5. And now when we scroll up and down our value, it moves in increments of 5 degrees. Okay, so I've just briefly touched on our constraints here. Now our constraints really are very useful within our sketching environment and with our overall design. So we will be making use of them plenty in the future. So let's erase this by window picking, erase, or I can press delete on the keyboard. Okay, so now I'm going to create a sketch that we will use in our 3D environment. So first I'm going to exit out of my sketch and delete all of the operations from my 3D environment. Okay, so if we exit the sketch, and notice we have nothing within our sketch, so we'll be asked if we want to delete it. In this case we will select no. You can see our sketch in our history. In fact, instead of deleting my operations, I'm going to just suppress them. Drag our model stop up to above the circle and use the suppress next operation icon to suppress our operations as we move through them. And then we will edit next operation. I'm going to edit our sketch. Left click. So I'm going to hide my 3D environment, and now I'm going to create a sketch. I'll start with a 2-point line, and I'm going to let the first point of this 2-point line be constrained to my y-axis, to an x value of 0. Left click. I'm also going to use my auto constraints, my snap tools, to get a vertical line. Okay, and you'll feel these snap in. Left click, middle click, and here is our line with a vertical constraint and an x value constraint. Now I'm going to use my 2D connected curves tool, which I can access by right clicking, first on the left at the top, and I'm going to draw freely. Holding down the Alt key. Middle click again. I'll use the same command again. Holding down the Alt key to create my 3-point curve. Middle clicking. Okay, now I can drag my points as I see fit. Okay, notice how these auto constraints are giving me difficulty when editing my curves. So I'm going to delete them by selecting them, left clicking, delete. Okay, so if you're not familiar with how I'm using these tools, please refer to the follow-up video where I go into great detail about all of our drawing tools and commands available to us. I'll use my slot drawing tool. Okay, it's important to note that most of the time we'll be wanting a sketch that is closed. It has no open gaps and it has no intersecting curves or an excess of curves. Okay, you can see here that this shape is closed. Okay, in the case of this shape, you can see here with our square, our little blue squares, that this shape is not closed properly. Okay, so I'm going to use my trim tool. Trim out this section. There we go. We have a complete shape. Now I'm going to make this curve construction geometry. The reason being is that I'm going to be revolving this sketch in my 3D environment. And here is our sketch. Now, like I said, a sketch can be used for many things. In this case, I'm going to be creating a solid by using our revolve command in the shape ribbon tab. So we left click to bring up the revolve input manager. We are then asked to select a profile, which we will pick as our sketch. Left click. Then we pick an axis to revolve our sketch around. The z-axis. We want one complete revolution, which is 0 to 360 degrees. Start angle is 0 and is 360. Okay, we can use the two sides or one side revolve type, as long as it goes from 0 to 360. We'll be bringing this in as a base. I'm going to leave this field for now, and I'm going to confirm my operation. And here we have a revolved shape, a lamp. Okay, so we can make changes within the history to our sketch, and this will update our revolved sketch. Okay, so like I said, we have two options available. We have the Redefine Sketch or the Edit Sketch. If I left click on the Redefine Sketch, it takes us back into our original sketching operation. Okay, and we can make changes here. We can drag and drop. dragging and dropping. And then we can exit out back into our 3D environment and then replay the rest of history, and our revolve will update to the new sketch. Okay, now we can also right click on sketch in the history and edit our sketch. The difference here is when we edit our sketch, we are still able to see the rest of the history operations. Okay, the history is not taken back in time to the point at which the sketch was created. We are editing our sketch with the rest of history still played. Okay, when we exit, we can see our sketch here and our shape. We then need to replay history by left clicking on this icon here, the regen icon, to replay all of history, and this will replay the revolve with our newly defined sketch. You may have to click it twice, and there you go.